Okay, Unit 7, Lesson 3 is Systems of Nonlinear Equations, which may be somewhat of a new concept for this course. So, but we're going to solve them the same way. You can solve nonlinear equations using both substitution and elimination. Okay, so depending on which equation it is, one method may be better than other. But because we're dealing with nonlinear equations, you might have to employ some of the other methods of solving after you substitute or anything like that. So difference between linear and nonlinear, we can see here that all the exponents are still 1. In this particular case, we don't have any variables underneath our square roots. Or in this one, we have exponents. We have variables under radicals. So we have multiple things going on. Okay, so this would be nonlinear. And this would be linear. So a system of nonlinear equations is any system that has one or more nonlinear equations within it. And so, again, anytime you have like an equation that has an x squared or a variable under the square root, if you have one of those, then it is now a system of nonlinear equations. And so here's an example here. We have 2y minus x squared is equal to 0. And y minus x equals 4. Those are both graphed here on your, on this graph. This, it's really kind of hard to read. Here's my x-axis here. And my y-axis here. Okay, so same thing as before. When we're looking for solutions to those systems, we're looking for the points where they cross. So if you're solving by graphing, you're looking for those points of intersection. And so here we have a point at -2, 2. And because one is a quadratic and one is a line, they actually cross twice. So we get 2 solutions for this system, the other one being at 4, 8. And so both of these are solutions to the system. If you plug them in, you should get that they work for both of them. Okay, well, as we saw in the previous lessons, graphing doesn't always work because it doesn't always give you real solutions. And so being able to solve using substitution or elimination is also important. And this system here is either set up for either, but I'm going to go ahead and use substitution on it. So I'm going to take my linear equation that I have, and I'm going to solve it for x. So x is equal to y minus 3 if I move both of these to the other side of the equation. Okay, so I can take this value then, and just like substitution before, I can plug it in for the x value up here. So we get y minus 3 squared plus y is equal to 9. This would need to be FOILed out, and that's where you need to be careful. So make sure you're doing y minus 3 times y minus 3. So we get y squared minus 6y plus 9 plus y is equal to 9. As soon as you see that squared, this is a quadratic, and that's what I meant by using other methods to solve it, is that now we're going to have to use our quadratic methods that we have. I'm going to get this set to 0 and see if I can just factor and solve it. So we get y squared minus 5y. I'm going to subtract 9 from both sides, and that gives me 0. So minus 9 cancels that out. This does factor, then I take out the y, and we get y equals 0 and y equals 5. All right, so we're not done yet. We weren't just solving for y, we also need to solve for x. So as you plug in, those give you your 2 different points where these cross. So if you have y equals 0, then that means that x is equal to 0 minus 3, which gives you -3. So that's the point, -3, 0. I plugged in the y this time. All right, you also need to do y equals 5. So x is equal to 5 minus 3, which is 2. So that is the point 2, 5. And so at these 2 points is where these lines will cross. Okay. And I always start with substitution because I tend to lean heavy towards elimination. Like up there, I probably would have used elimination and got rid of my y's first and actually ended up solving for my x's first. But it doesn't really matter. It's whichever method makes the most sense to you. And so for this one, I'm going to line up my like terms. And for the most part, they are lined up. So x squared minus y squared is equal to, I'm going to leave a gap, or you could put 0x if you want, plus 3. And then 2x squared minus y squared is equal to x, oops, sorry, this is plus 1, this is plus 3. These, because these are the same, I'm going to go through and I'm going to switch all of my signs on this bottom one. And I'm going to add down. And so this gives me negative x squared. The y squareds will cancel, equals negative x minus 2. Again, I see, as soon as I see that x squared, I'm going to move this and get it set to 0 so that I can solve it. And so I have 0 is equal to x squared minus x minus 2. And I moved my x squared over to make it positive because that's just much easier to factor. This is x minus 2 and x plus 1. All right, so x equals both 2 and negative 1. All right, well, because both of these are squared, these actually graph circles, and so they may cross more than just twice, but I need to plug in the 2 to solve for y. And so I go back and I pick one of my original equations. It doesn't matter which one you pick. I'm just going to do the first one because there's less to do there. And so 2 squared minus y squared equals 1. So 4 minus y squared equals 1. Negative y squared equals negative 3. Get rid of your negatives. So y equals plus or minus the square root of 3, which means that you have 2 and square root of 3. I'm kind of going off my page here. But you also have 2 and negative square root of 3. Both of those are points where they could cross. And we still need to plug in the negative 1. And so I do negative 1 squared minus y squared equals 1. So 1 minus y squared equals 1. Negative y squared equals 0. So y equals 0. So this one only gives me one answer. But I plugged in a negative 1. And I got out a 0. And so all 3 of these points are where they cross. And you think about the fact that they're both circles, then that makes sense. They could absolutely cross in 3 spots. Okay? So a little bit more elaborate when we're dealing with the nonlinear equations than with the linear equations. But for the most part, you're still just using substitution or elimination to solve these. And so go ahead and try this one on your own. Okay, so I substituted. If y squared is equal to x, then I can just take this x and replace the y squared, subtracted over, factored, and solved. So I get 0 and 3. So if 0 is equal to y squared, then that means y is 0. And the point of intersection is right here at 0, 0. We also have that 3 is equal to y squared if we plug that in for x. So y is equal to plus or minus the square root of 3. And so same thing, we have 3 square root of 3, or we have 3 negative square root of 3 for our solutions. You can see here's where x is 3, which means that this y value is then positive square root of 3 or negative square root of 3, where those cross. To graph this, either one of these, when we have a y squared, you would have to solve for y. And so if you have y squared is equal to x, obviously square root both sides, in your graphing calculator, you have to type in y equals the square root of x, as well as y equals negative square root of x. And that gives you then this side and this side. Some of the newer calculators may have the ability to change to an x equals instead of a y equals, but you usually have to run a program for that. So it's easier just to solve for y. Likewise with the top one, you would have y squared is equal to negative x squared plus 4x, square root both sides, graph both the plus and minus of that in your calculator. So you would have actually 4 equations graphed in order to see this graph the way it is. Okay, so sometimes it's just a matter of being able to tell what method is going to be easiest for you to use to solve it. So for this case, because we have a product here, you would have to use substitution. You wouldn't be able to use elimination for that. So like substitute in x equals y, or excuse me, let's put that upside down, 24 over y. And you could plug that in for the x. Or even easier, so that you don't have to deal with the 2, y equals 24 over x. Okay, and substitute that in. Likewise here, I would use substitution to solve if I were going to solve this one, because I can get this x by itself pretty easily. All right, or you can even, to get rid of this radical and not have to plug that in, you can say that y equals x squared, because you could subtract that and then square both sides. Okay, so that's kind of pushing it with the signs, though. I'm going to do x equals negative square root y, and I would plug that in there. You're going to square it either way. Okay. So really, you're just always asking yourself, what method is easier? Okay, and I can post a separate video and make it optional on how to solve these step by step. I just don't want to keep you too long. All right, but for here, I would use elimination, because we can line up these like terms really easily and eliminate the x squared. Okay, same here, elimination. But up here, I would multiply this top one by 2 so that you get 2x squared plus 4y squared. 4. And then we have 2x squared. I'm going to do minus 3y is equal to 15. Don't combine those, but if I subtract these down, then I get those to cancel. I get 4y squared minus negative. Remember, these signs are going to flip here if I'm subtracting. So plus 3y minus or equals negative 9. And then I can solve with quadratic formula or factoring or whatever and plug in. Okay, so get rid of your x's using elimination. Here, same thing, multiply through by 3 and get rid of your x's by subtracting. So 3x to the 4th plus 3y cubed is equal to 31. 3x to the 4th plus 5y cubed is equal to 53. Remember, when you take a cubed root here, so negative, you can take the cubed root of a negative number. Well, we won't need to, but you could if if you got that. So if y cubed is equal to 1, then y is equal to 1. All right. Plug in that and solve for x. So x to the fourth plus 1 is equal to 17. So x to the fourth is equal to 16. And x equals plus or minus, because it's an even root, 2. And so you have 2, 1, and you have negative 2, 1 as well. Okay, even on this next one, don't let all of these fractions overwhelm you. Remember, clear your fractions out. So we can actually multiply by x squared y4 on both the top and bottom. All right, and so then we get 4y to the fourth plus 6x squared equals, well, I could add a 2 in there also. Let's throw a 2 in there. Get rid of all of our fractions. So 8x to the fourth, y to the fourth, oh my gosh, plus 12x squared is equal to 7x squared y to the fourth. And then y to the fourth minus 2x squared equals 0. And you could solve it from there. Okay, you already have your common denominators. An even easier way to do that. Okay. All right, looking at this next one, don't let the fractions overwhelm you. Notice that we already have common denominators. So really, to eliminate something, you just need the same numerator. So this one's already set up for elimination. If I multiply this bottom one all by 3, then you would end up with 4 over x squared. 4 over x squared plus 6 over y to the fourth equals 7 over 2. As well as 3 over x squared minus 6 over y to the fourth equals 0. And so those eliminate if we add these equations down. They go away. And then these have a common denominator, so it's just 7 over x squared. Those then add 7 over 2 plus 0 is still just 7 over 2. And so if they have the same numerator, they have the same denominator, x squared is then equal to 2, and x is equal to plus or minus the square root of 2. We can then just plug that in, both of them in there. It's not going to matter because we're squaring it, whether it's positive or negative. So really, you can just plug in square root 2, solve for y, and see what you get. But don't let fractions or anything like that intimidate you. You're still going to approach it the same way you would if we were solving any other equation. You can always double check yourself in a calculator, or if the problem tells you to find all solutions and round to one decimal place, you're going to use your graphing calculator. Now, as nice as graphing calculators are, as I was talking about earlier, you still have to solve for y to be able to utilize them. And so for equation 1, you would need to do y is equal to plus or minus, so you do both, the square root of negative x squared plus 12. And I skipped a lot of steps there, but you subtract the x squared and then square root both sides. And then the bottom is already ready to type in. But this becomes equation 1a and equation 1b, if you will. What I would recommend is, since you have access to it on your laptop, if you go to Desmos, you don't have to solve anything. You can just type it in. And in fact, you don't have to go through all those steps to find points of intersections. You can just tap on them and it gives you that decimal approximation. And so I would definitely probably just use Desmos for this. But you can use whatever you want. Okay. And then the last aspect of this is word problems. And again, you're still solving using systems, so I'm not going to solve these, but just look at how to set them up. A circular piece of sheet metal has a diameter of 20 inches, and so this diameter across is 20. The edges are to be cut off to form a rectangle with an area of 160 inches squared. So this is 160 inches squared in here. What are the dimensions of the rectangle? All right, so with this one, it says it has a diameter of 20, and we need to kind of see that in terms of this rectangle. So if we draw the diameter of a circle, we can connect the diagonal of your rectangle. And so this is 20. And so this creates this right triangle here. Well, in a right triangle, a squared plus b squared is equal to c squared. So in this case, 20 squared. So let's put this as the width and this is the length. We will have width squared plus length squared is equal to 400. Area we know is 160. Area is also length times width. So length times width is 160. All right, I would probably use substitution for this and put like L equals 160 over W and plug that in. Or solve up here for L or W and plug it in down here if you don't want to plug in fractions. So you could say L is equal to plus or minus the square root of 400 minus W squared and plug in both the positive and then the negative down here and solve it that way. Okay, so that's how you would set that one up. And this one, a hill is inclined so that its slope is 1/2 as shown in the figure. We introduce a coordinate system with the origin of the base of the hill and scales, axes measured in meters. A rocket is fired from the base of the hill in such a way that its trajectory is this parabola here. At what point does the rocket strike the hillside? How far is this point from the base of the hill to the nearest centimeter? Okay, you can see from the diagram that the hill starts at 0, 0. It tells you that its slope is 1/2. So your first equation is just y equals 1/2 x. Right? Your second equation is given to you, y equals negative x squared plus 401x. This one is just a straight substitution problem. We're going to plug this in right here for y. Get it set equal to 0, factor, and solve it, and it will tell us where that will land. Okay. All right, so that's pretty much it for those. Again, I'll post a longer video with the full solutions to these problems in case you're confused on how to solve them. You're welcome to watch that. I won't do it through Edpuzzle. I'll just post it on Schoology. Okay, have a great day.